Okay. So where we were.
Okay, I will explain. I think
Uh,
in the break.
okay.
Okay, initially the cap will be shorted. V out goes to 0.
Hmm.
The mass is in whatever this linear region. It will act as a resistor. So the mass is mass takes some current and it will get charge. Okay, it will get charge because of that one. Whatever this saturation condition according will not occur.
Saturation condition will not occur.
Will not occur.
Okay.
What I think that I will explain here.
Hmm.
Okay, always this resistor takes 5 volts drop.
Always that resistor takes 5-volt drop.
Yeah.
Okay, that's fine.
Why? Because it is taking 0 amperes. This I naught 5 milli is continuously flowing through
Yes,
the
yes, yes,
resistor.
yes. So
Uh,
okay. You mean
always
to
5
say
volts drop.
get to drain of means transistor is always 5-volt.
Yeah, yeah.
Hmm.
GD.
Get to drain
Ah,
voltage I am talking about.
yeah, yeah, yeah. GD. VGD.
Yes, yes, VGT.
We get to
Spaces.
drain. It is always greater than threshold.
Okay, where are you writing? Start writing below this. V naught will not occur
Yeah.
somewhere here.
Okay. 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 Here, see.
Okay.
Is it visible?
Now it is visible to me. Yes, yes, yes.
Okay. VGD always greater than 0.5.
VGD is always greater than 0.5. Why 0.5?
0.5 our threshold voltage now. To compare, it is in linear or saturation. I am saying that now.
Okay.
VGD always VGD that is 5. It is always greater than 0.5. So it is always in linear region only.
Yes.
Okay. It will
Hmm.
never go to saturation region. That is my
Then
first point.
okay.
So I can replace. Okay, okay. Sorry, sorry. Can you move it
Yes.
a little bit up?
Little bit up. You want more space, huh?
Yeah, yeah.
Okay. Now you start writing from this point. You will start
Can I
from.
write this right side? Right side.
Is it visible
Here.
for you? Clear?
Yeah, yeah, clear. You are
According
on
to.
left side. Come to the right.
Okay. Anyway, you start writing. You start writing.
Okay,
Uh,
okay.
it is visible on your screen
Okay.
now.
Can I clear the page?
You will clear, then complete things will be cleared. Better to like you write here now.
Yeah.
Somewhere you can write it will be visible, no problem.
Okay, okay. See here. Here and now I can replace completely my. Are you visible?
Still it is not in my range. Fine, wait. Now I can
Okay.
see you. Yes, yes, now I can see.
Okay, okay. See. This is my
Okay.
now complete my picture. Why? Because of it is always linear region. Can also now I replace this whatever this mass with resistor.
Okay.
It is 5 volts always. It is 5 milliamperes. It is giving. Now the thing is, so it is like the cap will whatever this V naught is getting charged linearly. Not linearly, exponentially.
Hmm. Okay. Capacitor is charging
Exponentially.
exponentially. Okay.
Uh, at steady state, it will reach the sorry. It will get open circuited. This is my steady state voltage. Across
Hmm.
this, whatever the voltage across the R on will be voltage is there. That voltage will be getting to be settled. If I want to that settling voltage, if I want
Hmm.
to be that, my
Okay.
R on will be 1 by what is the mu and C ox W by L value?
That is 200 microampere per volt square.
Okay, 200 micro.
Hmm.
My VGS, my whatever the VGS is V naught plus 5 minus threshold voltage. Vs minus VTH. This is
Wait.
my R on.
Wait, wait, wait. Okay.
Uh, At steady state, I want to flow my entire current through this R1 only. There will be no current through the cap.
Okay.
That is my steady state.
Hmm.
Okay. So
Hmm.
that 5 milli equal to that current equal to that voltage by resistance. By
What is
resistance
this 5
means
milli? What is this 5 milli R1? R1 is 5 milli.
not R1 5 milli. This
What
is
is
one
this?
expression. This is one.
Okay.
My 5 milli will be V naught by R1 at steady state.
V naught Y R1 equal to 5 milli.
Yeah.
How this 5 milli number came? That's current you are talking now. Okay, means
Yeah,
entire
yeah.
current will, yeah, this entire input current is flowing. Okay,
Yeah,
fine,
yeah.
fine.
At
Yes, fine,
steady
fine,
state,
fine.
the
Yes, yes.
entire current flows through R1 only.
Okay, okay.
Then I can write that 5 milli equal to that V naught is V naught in the sense V naught steady state value.
Hmm.
V naught steady state value into 200 micro. That is like zero point 0.2 milli. zero
So what
point
you
2
got?
milli
You got number
V
or
naught.
V naught here
I will get V naught here.
because of two equations.
Ah,
Okay.
I will get how much V naught will getting to be settled. I
Hmm.
am saying that one.
Okay.
For which voltage it is getting to be settled. I am saying that
Hmm.
one.
Okay.
Hmm. And
Okay.
this one cancel. This is 1 by 5. This is 25. 25 equal to V naught into V naught minus 4.5. If I solve this one, I will get V naught steady state value.
Hmm.
Hmm.
You got it.
Yeah, yeah.
How much you got? Steady state value.
Okay, I didn't solve this one. I got it in a sense. Okay. Okay.
Okay. So what is the time constant for the circuit?
For this
Charging
circuit,
time
na?
constant that you have for the time the charging time constant for the circuit.
Okay, okay. Hmm. It is time constant will be R1 into C. This will be the time constant.
Time constant will be R1 into.
C.
Is R1 fixed?
Now, R1 is not fixed.
It means time constant is also changing.
Yeah, yeah.
Time constant is also changing. Then why it is constant?
Uh,
We are saying the time constant.
okay. It is not fixed. Time constant will be t greater than 0.
For a circuit, if time constant itself is time dependent, then how do you define settling?
Yeah. Mm, R1 is not fixed. So time constant, I think some other way. Mm. I think I have to take initial R1, starting R1, I think, at
Hmm?
equal.
So
Hello.
which time constant you are defining then? You are saying the time the R naught is also changing, R1 is also changing.
R1 changing. I think I will take at R1 value at equal 0 or something.
What is the maximum or minimum value of R1 you are getting?
R1, na?
When it is maximum, when it is minimum?
Mm, Yeah, maximum will be whenever V not get settled now. Then only I will get the output after getting output settled. Then I will get R1 will be minimum.
Why?
Initially, R1 will be maximum.
No, no. Why minimum when output is settled?
Why in the sense when output settled now, V not is reaches its maximum value.
Okay. Then
If it is maximum now, then my overall R1 will be getting to be very low. When it is maximum, my R1 will be minimum.
okay. So what is the exact expression of Aaron?
What?
What is the exact expression for Aaron? Exact expression with the current equation.
That will be WL Vs minus Vth into Vds minus
Yeah.
Vs square by 2. We will
Yeah.
take for
Wait. Wait.
R1
Wait.
1
Wait.
by
Wait.
dou
Wait.
Id
Wait. Wait.
by dou Vds. We are approximating this. This is P10. Vds is Vds is much less than the Vgs minus Vth over, right? So that's why we are eliminating this thing. Then we will get this expression.
Okay. So you mean to say VGS minus VTH is only in the denominator? Fine.
Yeah.
Okay. So we are ignoring VDS by square by 2 in front of this VGS minus VTS times VDS.
Yeah.
Okay. But what is the steady state value of VDS? Is VDS is affecting or around not?
Where in this circuit you are asking me?
The maximum value of VDS is what? If it is of
E-
order of like 1 volt or 2 volt, then
Okay.
it will be
You are asking for
significant. Na?
this circuit or generally?
For this circuit only, no? I mean to say,
Uh, okay.
I mean to say what? I mean to say, if this expression is there, if we find del ID by del VDS, then usually it boils down to some constant VGS minus VTH
Okay.
minus VDS. So R on boils down to 1 upon some K VGS minus VTH minus VD. So I mean to say, is this VDS always ignorable or not?
Not ignorable. Whenever this, whatever this VDS is much less than VGS minus VTH, then only we
So
have to.
my point is that on one end you are saying your VGS is increasing.
Yeah.
At the same time, my VDS is increasing. The change in VDS is equal to change in VGS. Then it is looking like
Okay.
relevantly like this is also increasing, this is also increasing. So effectively, for me, it is looking like there is no change in RO. Why you are saying the RO is changing?
Okay. Okay. Then I have to consider here minus V naught also. Then my R1 should be constant.
Hmm?
If I consider that VDS also,
Hmm? Then
this is then R1 will not vary. It is
but
constant.
RO, do you think that it will be constant? But you told one more condition there. If there is the possibility of like VGS minus VTH, if this thing is holding for you, then you are saying we will ignore this VDS. That is fine also. And why you are saying why are you not
While
ignoring VDS now?
calculating, now it is get VGS minus Genius.
Why are you not ignoring VDS? Why are you considering V naught here and cancelling V naught? You should ignore it now.
Why? Because of this, whatever this VG and VD are separated by just 5 volts only here.
Hmm.
So it should be considerable. It is not like neglecting condition.
So it should be considerable.
Yeah, it should be considerable.
So your RN should be constant according to you.
Yeah, according to this one, if I consider VDS effect in this RN, then my RN should be constant. Then tau
What?
will be exist.
How will be?
Exist finite.
Okay. So, okay, we concluded many things here we discussed. Okay, fine. Now I
Okay.
think I should. What was the question? Question was this: CL, RF. I am pumping a current.
Yeah.
Okay, so we have calculated V out. Fine.
Mm.
So if I want to see here, like what I mean to say, transfer function wise, I want to see the poles
Yeah,
and
poles and
zeros also. Not
DC
complete
gain also.
transfer, not complete transfer function. Just I need like some way of finding them with
Mm.
intuition, whatever.
Yeah, yeah.
You can start.
Okay. Mm. For the whatever this. Mm. I can say for pole C equivalent will be CL.
For C equivalent equal to CL, okay.
Okay. While coming to the R equivalent, I can take, I will nullify the input.
Hmm.
I have to apply Vx here, Ix. If I find the Vx by Ix, I will get R out or R equivalent, anything.
What is that?
For that one, the same node Vx will coming here. GM times of Vx are coming here.
Hmm.
Okay.
Hmm.
Then that Ix equal to, I can say Ix equal to whatever the Ix is flowing through this one. This is 0 amperes. Same Ix is coming here.
Hmm.
So Ix equal to Gm times of Vx. Vx by Ix equal to 1 by Gm.
Okay. So why you did this calculation? Did we can directly see this thing, na? Diode connected
Yeah, we
transistor.
can see. Yeah, yeah. It is direct. Even
Diode
though the
connected transistor.
resistor is there or not, we can say it
Yes,
is 1 by
yes.
Gm.
Okay.
Yeah, yeah. Uh,
So what is the pole
so
then?
I can say minus 1 by whatever Gm by Cl. This is my pole.
Okay. What is zero?
For the zero calculation, I can do like Okay. Normally, 0 will be existed only at omega equal to infinity only.
Why? Not on finite
This is my
frequency?
0. Yeah, we cannot get at finite frequency.
Okay. So
Mm.
what are the conditions you apply while calculating zero, and why these conditions are
I
not
will
here?
calculate. I will see the basic principle of from input to output. I will see any multiple frequency paths exist or not.
Hmm.
There will be a resistive element. So normally, because of this only load cap, there will be no other cap here we consider. So that's why there will be no in that manner. Also, if I do if I do whatever that from input to output, any node can be make infinite impedance that will make that there will be a disconnection between the input and output. Then also output will be getting to 0, which leads to transfer function become 0. That is we can consider as a 0.
Okay, fine. So you got pole. Fine.
Anuj?
Got the point.
Yeah.
Okay,
Yes.
so this is enough discussion for this question.
Okay.
Now we'll shift to new question. Yeah. Okay. I think it is not properly written. Okay,
Yeah.
that I can say C G 3 4. Okay. So what you want from input to output transfer function, V into input is a differential
Okay.
PD. Here I want um, like first word I want exactly the loop gain from input to output. First loop gain I want, then the open loop gain, whatever you can calculate, and whatever I mean to say, closed loop gain, all the terms, loop gain, open loop, and closed loop transfer function. I exactly means the complete frequency analysis of this, where poles and zeros are lying. We have two VD transfer function,
Okay.
and are you able to see the feedback here? So with that, you have to calculate loop gain also.
I can say it is in negative feedback, disconnected in unity negative feedback.
Hmm.
Why? Because of this minus statement directly connected to the output. It is like I can say in this manner.
Okay.
So
Okay.
it is unity feedback.
So you need to compute the loop gain, and I want a UGB also.
Okay, okay. I will say for this one. R equivalent. Okay, the pole due to the CL cap is CL into this R04 parallel with R02. The whatever this pole due to this CGD, this one will be like CG3 GM4 by GM3 by CG3. I want look and to post. I will be getting 1 0. The TC gain for normal thing without any feedback. Like I can take this GM is GM1 and R03 R02 parallel with R04. So I can say UGB will be this is the I can answer a dominant pole like DC gain into first this pole dominant pole. I can say this one as this is my UGB.
What are the UGB? GM1 by CL. Okay.
Yeah,
Okay. What about zero? What about zero?
zero
Is it possible to have zero here or not?
zero from input to output. If I like anything, because of this CG3, it may cause us to the zero.
So what will be the location?
Location of the zero. Zero, but there will be a zero because of this CG3.
Why and how?
While going to the input to output, it offers a different frequency path compared to this resistive path.
Okay. Then why are you not able to calculate it?
something, this will be some voltage Vx.
Hmm.
Okay.
Hmm.
I'm getting I1 current, I2 current. I want to make I1 plus I2 equal to 0. If I make that 0, it is Vx by the tar is nothing but again. Okay, I got it. I think this is uh, yeah, okay. Vx by R is 1 by Gm3. Okay, so I equal to V by Cg3. Normally, I heard that it will be exactly twice of this pole. Normally,
You read it, but cannot you calculate it?
I didn't calculate, but now I am trying. But it is getting same equal as the pole. But it should not be happens like that.
It should be doubled. Huh?
It should be doubled. I heard. No. But I
You heard
didn't
it, huh?
tried. Yeah, I heard
So
it.
you try it in free time. Okay.
Mm. Is it
Is-
right or not? It is getting twice of that pole.
Yes, it comes at twice.
Okay, I will try.
Okay. So the third question for you is from two-stage amp because you told that you designed two-stage amp.
Yeah.
Wait. Yes. What time remained is 6 minutes for this session. Okay, we'll just finish
Okay.
it soon. Okay, so what is your job in this question? You have to see whether this is connected in proper feedback or not. Is it a stable
Okay.
system with respect to the feedback wise? That is positive feedback, negative feedback. So first look at the feedback.
Okay.
Okay. If there is any problem, then which particular blocks of GM you will need to change the sign and why? Which is the GM1, GM2.
Okay.
So you see whether the
Normally,
yeah GM blocks are signed properly or not. That sign I have given.
okay. Whatever this block has to be worked as a normally I want to be current controlled voltage source. It should be inverting amplifier, but we were connected to positive terminal. This should be interchange.
How you are looking this that it is stable or not?
Yeah. This one.
Hmm.
These two. whatever this plus and minus has to interchange.
What about the first block?
The first block, while connecting to the unity negative feedback output to input, we have to connect it to the negative terminal.
So it should be also changed.
Normal, this connection has to change.
Connection has to change.
Not connection. Okay, okay. It is, I think, plus or minus. Okay, not input anywhere. Plus. It is fine. I think this is the only problem. Internal, internal GM cell.
Okay, so this sign should be changed, huh?
Yeah.
Outer is fine.
Outrace, while usually we will give in this manner, VD, for the purpose of getting current inside of this GM cell.
Why inside, not outside? If it is going
Normally, it
outside, then what's
can
the
go.
problem? Cannot you check the feedback
Uh,
here? If you are breaking the loop somewhere and you are increasing the voltage like that, you can check. No? Why you are going with this way that inside? It is not a fixed that I want inside current or outside current. But you can break the loop
okay, okay,
anytime and add in place, and you can see all the loops inside the system are negative
okay,
loop
okay.
or not.
I will increase
Uh,
this. I will increase this node.
okay.
This node also increases.
Hmm.
That leads to it increases.
Hmm.
That leads to this again increases. It is connected in positive feedback.
Okay. So if I like change this sign, then what is the problem?
Okay. This is minus. This is plus now.
Yes. Then see in the same way.
It increases. It will decreases. Then it looks like whatever this negative feedback. But my point is this internal structure should be inverting op amp. It has to be acts as inverting.
Is it inverting or not as of now?
As of now, it is not an inverting op amp.
No, no. You told that you increased output voltage. This terminal voltage increased. It means
Hmm.
current reduced. So this voltage went
Yeah,
down. If this
yeah.
down, if this
Overall
going down,
output will be down.
it will be down.
Yeah.
Okay. So it is not. So overall outer loop is looking into negative feedback.
Yeah. Outer loop is looking like negative feedback.
What about the inner loop? Where is the inner loop?
Inner loop, what?
Where is the inner loop?
This one.
Wait, what about it?
But it is we generally take care about in inverting. Why? Because of that current has to convert into voltage. It has to
So
sense the current.
okay, fine, that I
So
got.
that's
But
why
is this like inner loop has positive or negative feedback? Can you see it?
inner loop is in positive feedback.
So the sign should be changed.
Yeah.
So now let's change the sign.